Good afternoon, everybody. Welcome to another week of organic chemistry with your host, me, Dr. White. Actually, just today and Wednesday. Don't want to scare you. But anyways, hope you had a nice time since we last met. I did a lot of yard work, mowed my lawn, cleaned my house, did a lot of other goodies. So I'm in a good mood, all fired up and ready to go. And don't forget, be talking about my comfort zone functional group or comfort functional group, that's ketones and aldehydes. So before we start, any questions from anybody? I see something on the chat. If you, JC, if you lose, uh, that's fine. Come right back when you get, I've had problems in the past, luckily, with my internet service. I understand. We're going through some trying times. It's a lot easier just walking into a classroom. You're there, I'm there, the whiteboard works. All right, let me remind you, I think I said it for Wednesday, but if not, I'll do it. This Wednesday, I'll be going through the epoxides and ether problem set. So I'd highly recommend you do that before I do. And that way you'll keep on schedule. And I looked at the schedule, we're doing real good, which makes me feel good because this way I don't have to rush, which usually I don't because I know how to plan this. And it's working good. All right. Well, let's get back to where we left off. I was talking about aldehydes and ketones. Let's do a little quick review. Remember, aldehyde is a compound. Let's see if my switch is working now. All right, if you see a long line like that, I'm going to have to change the switch. It just started doing this on my tablet, but it still works. An aldehyde is where you have a carbon double bond to oxygen with a hydrogen R group. Remember, R can be anything with carbon hydrogens. And then a ketone is where you have a carbon double bond to oxygen, and you have two R groups, not an R group and a hydrogen. And one of the most important things I can teach you is the carbonyl group. And how do you draw it? Carbon double bond to oxygen. And you should know how to describe it with words. Carbonyl group is a carbon or carbon atom, double bond to oxygen atom or just oxygen. And this is how you write it. And you should know that. I'll say that again. Hint, you should know that. I'm being subtle today. Really, it is that important. Now, for nomenclature, find the longest chain. We went through this that has the carbonyl carbon, carbon double bond to oxygen. Name it as an alkane, drop the E at the end of the alkane, and replace it with an Al. Now, let me warn you, alcohols have an I apologize. I'm going to swap out that switch soon. But anyways, alcohols have an OL ending. Aldehydes have an AL ending. When you're writing this on the test, make sure your OL and AL are clear. You don't want me guessing because there's a 50-50 chance I can guess wrong. Now remember, the aldehyde carbonyl carbon is always one, so you don't need a number. Let's do a practice problem. So like I said, we're doing good on time. And what would be the IUPAC name for this compound? Go, your turn.
I can't see anything.
You can't see anything. Somebody should have screamed at me before then. Thank you for letting me know.
Yeah.
Now can you see it? Thank you, Alondra. And when you're done, give me a thumbs up or smile or give me the high sign. All right, looks like everybody's done. Let's take a look at this. What do we have that's different? Oxygen. Remember, when you're looking at a molecule, look for what's different. These functional groups, look for what's not carbon, what's not hydrogen. Oxygen, carbons, carbonyl. We have an aldehyde. And how many carbons in the longest chain? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So the longest chain is 6. That's hexane. It's an aldehyde. Drop the E, add Al, hexanal. This is carbon number 1. You don't put that down because everybody knows that. And what's this? Oh, it's Dr. White's favorite group, the T-butyl group. If you want to put tert-butyl, you can. Organic chemists don't. And it's on carbon 2. So this is 2-tert-butyl hexanal. Aren't you glad I'm not giving enunciation quizzes? All right, let's move on. Everybody see ketones on the screen now? Thank you. All right, remember ketones find the longest chain, which includes the carbonyl carbon. Name it as an alkane or cycloalkane. Drop the E at the end of the alkane name or cycloalkane. Add ONE for carbonyl carbon. Carbonyl carbon is always the lowest number in a acyclic compound, and you do need a number. In a ring, it's always number 1, and you don't need a number. And why don't you give the IUPAC name for that molecule? If you lose me, sorry about that. I tried to do something that made it worse. During the break, I'm going to swap out that switch. Maybe not. All right. Let's go and do this. All right, what do we have? What's different? Up here, oh, look, I have a carbon double bond to oxygen, carbons here and here. That's a ketone. And how many carbons along this chain? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oops, hexane again. It's a ketone. Drop the E, add ONE. If this is carbon 1, this is 2, so it's 2-hexanone. And if this is 2, this is 4. Oh, it's your old friend, the methyl group. And that's 4-methyl-2-hexanone. And while we're in the neighborhood, and why don't you try this one? What would be the IUPAC name for the following molecule? Anybody knows of a better 4-hub USB besides Sabrent? Let me know. I'll be checking later today, Amazon. So I've been using these, but they do fail. The cord coming out of there is very tiny, and I think the wires finally give out. Or it's Friday the 13th, and the computer gremlins are getting me. All right, is everybody done? Yep. All right, what do we have? Ooh, oxygen, double bonded to a carbon. Carbon's here, here. We have a ketone. And how, ooh, we've got a ring, 5 carbons. That's cyclopentane. Drop the E, add ONE. This is 1, therefore this is 2, 3. And we have an N-propyl and a methyl. So it'd be 2-methyl. Don't erase your answer yet. 3 N-propyl. Cyclopentanol. Well, that's a mouthful. Now, on a test, if you put 3 N-propyl first and then 2-methyl, I would give you full credit because I'm not holding you to the IUPAC alphabetical rules, but I hold myself to those rules because at my level, I'm expected to get it right, and I hopefully do. All right, let's get back to our chapter. And now, 2 important common names I talked about. You should know that the structure of formaldehyde, which is the simplest aldehyde, and there are 2 ways you can draw it, is this molecule. And I talked to you about the dangers of formaldehyde. And then you should know how to draw the structure of the simplest ketone, which is acetone. Ooh, that reminds me. First of all, I'll wait until, in case any of you are copying that down. And that reminds me, did any of you happen to drive by a gas station and think about the fact that in gasoline, there's ethanol and alcohol? Did any of you happen to pick up a bottle of rubbing alcohol and look at the label and see it has isopropyl alcohol, also known as 2-propanol? And guess what? Isopropyl alcohol is an alcohol too. Or did you happen to take the nail polish off your nails with acetone and think about that's a ketone? Remember, organic chemistry is all around you, and it won't hurt to think about it outside of my classroom. Well, we did this in alcohols, primary alcohol oxidized to an aldehyde. Secondary alcohol oxidizes to a ketone. And remember, tertiary alcohol you can't oxidize, but that's another chapter. We already did that. Next, I talked about Friedel-Crafts acylation. This is one of those special ways of being able to make a carbon-carbon single bond, take a benzene ring, react it with an acid chloride, aluminum trichloride, and you make an aromatic ketone where one of the R groups is a benzene ring. Now, on test number 2, there'll be 3 synthesis problems, so let's try one. And there you go. What would be the 2 things you'd need to react with aluminum trichloride to make this compound. By the way, that's a C double bond to O. And I'll let you try it first, and then I'll do it. And when you're done, give me a thumbs up or some other way of letting me know you're done. I'll give everybody 30 seconds more. Everybody's smiling because it looks like you're having fun with ketones and aldehydes like I am. Bet you never thought organic chemistry would be this pleasing. Everybody go like this. Thank you. All right, let's do this. What's different? Ooh, a benzene ring. A carbonyl and carbons here. This is an aromatic ketone, aluminum trichloride. And what do you start with? A benzene ring plus an acid chloride. What's our R group? And propyl. The carbon with, what am I saying? Well, the carbon with going to this carbonyl will be the same carbon here. So my answers here are benzene plus my R group is that, and I have this acid chloride. And that's how you do synthesis. By the way, synthesis is the most fun part of organic chemistry, but I'm biased. I'm an organic chemist and synthetic organic chemist. Now, I talked about the carbonyl, and I showed you how the carbonyl carbon is where all the fun is. And we went through this reaction, which is the reaction or formation of hemiacetal hemiketals. Remember, if R prime is hydrogen, it's an aldehyde. If R prime is carbons, it's a ketone. If you react it with alcohol and acid catalyst, you form this hemiacetal or hemiketal, which we went through last week. But repetition is good for your grades, so let's try one. And why don't you try this? This reaction and next three, I will never put a synthesis problem on the board. All right, sorry about that. I was sneaking off and looking on Amazon for USB hubs, and right after class, I'll be ordering one. I have Amazon Prime. All right, let's go back and look at this. What do we have? We have an aldehyde. Look for what's different, and I'll write it down here. What's different here? Ooh, oxygen with a hydrogen and a carbon, alcohol. And this could have been a ketone, but it's an aldehyde. I have an alcohol plus acid catalyst. And what do I get? Keep your eye on the carbonyl carbon. What's ever attached to it, H or R prime, and R double prime is still there. This opens up to an alcohol, actually not an alcohol hydroxyl group, and the alcohol OR is attached to that. So here's my carbonyl carbon. I can call that R prime or H. This is R double prime, and here's my R group. So I'm going to put what was the carbonyl carbon, has H, 2 carbons. Then hydroxyl group, oxygen. Then the carbon with the hydroxyl group and the alcohol is the carbon attached to the oxygen there. And that's how you do that. I'll never put a synthesis problem on here. Everybody with me? Any questions? Again, what's your cat's name?
Her name is Peaky.
What?
Peaky?
Is that with a P?
Yes, P-I-K-I.
Oh, Peaky. Okay.
Yep.
I thought I heard that, but I've never. Say hello to Peaky for me. If she starts, you know.
I'll let her know.
All right. That's the one nice thing we don't get in a classroom. People bring their pets to class. All right, let's continue on, because I did want to review this because it's the more challenging area of the semester, actually. Now, another reaction which I covered on last Wednesday, you take a ketone or aldehyde, if R prime is H, it's an aldehyde if it's carbon's ketone, and now 2 molecules or moles of an alcohol acid catalyst get an acetal or ketal. Again, keep your eye on the carbonyl carbon, because that's where all the fun is. And let's take a look at this. Another problem, I'll let you try. And again, I apologize. You see all those disgusting lines on my tablet or your screen? Don't buy Sabrent USB hubs. They fail all the time. I should have known better. This one's lasted for a while, though. Almost since the beginning of summer. Wow, whole 5 months. All right, I think everybody's done. Let's do this. All right, what do we have that's different? Ooh, oxygen. Double bond to carbon. Carbon's here, carbon's here. It's a ketone. Could have been an aldehyde if our prime was hydrogen. And then what do we have here? Carbon, ooh, oxygen with a hydrogen and a carbon. And there are two of them. That's an alcohol. And notice you have acid catalyst. H plus is acid, usually sulfuric. It can be other ones that I'm not teaching. Keep your eye on the carbonyl carbon. What's attached to it? R prime and our double prime are still there. Then it will have two oxygens, and on each oxygen, R group. And now if we look here, our prime and our double prime are methyl. R is an isopropyl group. Just think about it. 6 months ago, if I had said isopropyl group, would you even know what I'm talking about? Aren't you proud of what you're learning? Doesn't that feel good? All right, so keep your eye on the carbonyl carbon. I'll draw it there. What's attached to it? The two R prime and our double prime are still attached to it. Now to this carbon, I'll put an oxygen and a second one. And now the carbon with the hydroxyl group will be the carbon attached to the oxygen here, which is the center of 3 carbons. And you do the same for the other oxygen. Let me put it over here. And you all know there's 4 bonds to carbon. Whoa, that's a big molecule. And that's how you get it. Oh, let's do another one. I see people are still copying it down, just checking it out, so I'll hold off. Water break. All right, let's do one more. And why don't you try this reaction? What would be the organic product or products, 3 points each, for the following reaction? Those of you who finished early, please be patient. Other people, I'm giving you a chance to finish. But doesn't it feel good you know how to do it? All right, I think everybody's done. Let's do this. Let's look at each molecule, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atoms. Oh, look, I've got an oxygen to carbon. Carbon's here, carbon's here. This is a ketone. It could have been an aldehyde, but it's a ketone. And it's a ring, a cycloketone. Dr. White and Mother Nature really love cycloketones. What do we have here? Carbon with the hydroxyl group. Two of them, it's an alcohol. And then H plus acid catalyst. Keep your eye on the carbonyl carbon. Remember, you don't break carbon-carbon single bonds, so it's attached to it, is still attached to it. You'll have two oxygens on this carbon, and each one gets the R group from the alcohol. So what's my R and R prime? The whole ring. So let me come over here, give myself a little more space. Now, which carbon had the carbonyl? This one. What's attached to it is still attached to it, the ring and the methyl group. And now this carbon, which is this carbon, will have two oxygens, and each one has a methyl group. And that's how you do it. Now, I'll give you a chance to write down if you're checking if you did it correctly. Now, one of the things I've been telling you, and I mentioned with this, is you should be asking more and more, why am I learning this stuff? And I know that for you, the obvious answer is you want to get a good grade and get into a school or program that requires you to take organic chemistry. But why take this? Well, the last two reactions we just practiced, making a hemiacetal, hemiketal, and making a acetal or ketal, are the two reactions Mother Nature uses to make all carbohydrates in our daily life. If you like the good things like potato chips, french fries, pizza crust, all other good things, potatoes and rice, plus if you like the fact that trees are outside your house or grass, those are all carbohydrates, which I'll teach you about later in the semester. And Mother Nature uses those two reactions to make them. Now, the next two reactions, Mother Nature uses them to break them down. These are reactions going on, don't want to scare you, but in your stomach. And let's take a look at them, at least one of them first. And that's reversing or acid hydrolysis of a hemiacetal or hemiketal. And what happens is you get back, here I have a hemiacetal. If R prime is hydrogen, R prime is alkyl, hemiketal, add acid and water, and you get back the ketone and the alcohol you would have used to make this compound. You're just reversing it. And I forgot, must be the FBI. Hold on one sec. Whoever that was, just hung up on them because I don't know their number. And it's probably a robocall. If not, they'll call back. I don't know about you, but I have Bluetooth phones with all the phone numbers of people I know. So if I don't know one, I don't answer it. Anyways, back to this. Question I was going to ask you was, wherever you are, if I said, quick, get me some acid and water, where would you find it? If you're in your living room, bedroom, family room of your house, where would you find acid real quick? And the answer is your stomach. One of the great wonders of the world is, and or nature or life, is we all have cells in our stomach that make hydrochloric acid. And you've also got water in there. And that's how you do the following reaction. It doesn't matter if you put water first and H plus second. And the question is, hold on. I'm writing the same thing, but I wrote it too close to the top of the page break, so you didn't see it. And the question is, what's the organic product or products that are following? Now, watch closely. If you notice, we look at this molecule, what's different? Ooh, oxygen here attached to that carbon. Another one, this has an R group on it. This has a hydrogen. There are only two cases in all of organic chemistry where you have two oxygens singly bonded to a carbon. This is one, the other I'll teach you later after the break. I already got this. And if we look at here, what do we have? A carbon with carbons on it, hydroxyl group, oxygen with carbons. So what is this? This is called a, in this case, this would be a hemiacetal. I'm not ever going to ask you to learn the names for these four reactions. What happens? Keep your eye on the carbon with the two oxygens. That becomes either a ketone or aldehyde you would have used to make this compound. Next, you also get the alcohol you would have used to make this compound. And therefore, if we look here, what's our prime? Hydrogen. What's our double prime? Methyl. What's our ethyl? Keep your eye on this carbon, becomes double bonded to oxygen. What's attached to it here and here, not oxygens, but hydrogens or carbons that are still attached to it. And then you get an alcohol. The carbon here attached to the oxygen will be the carbon that has the hydroxyl group. In this case, you get ethanol. And that's how you do it. All right, I'm going to give you a 6-minute break because I'm going to swap out this bad USB hub. I'll see you after the break. Have fun. And with that, I'll see you in a little while. All right, sorry about the delay. Let me try one more thing. Give me one more minute. Again, I apologize. Let's see. No, I don't know what it is. Well, I'll probably reboot my computer after class. All right, let's get going. And I just showed you how to do acid hydrolysis of an hemiacetal or hemiketal. So now it's your chance to try one. And there you go. At least I don't have to take out my little whiteboard and my markers and hold it up to the camera. Looks like I scared away everybody else except you two. Hang in there. But then again, I spoiled everybody because they know they can catch everything in my YouTube video. All right, I think everybody's done. Let's take a look at this. What's different? Hydroxyl group. Ooh, one oxygen, two oxygen, single bonds of the same carbon, with carbons here and here. This is a hemiacetal, or in this case, hemiketal. That should be an H. And keep your eye on the carbon with the two oxygens, single bond to it. What's attached to that carbon? R prime or H. And carbons, our double prime, are still there. That's double bonded to the carbonyl or to an oxygen, form a ketone or aldehyde. Then the R group here becomes this alcohol. In this case, what's our prime? This methyl. What's our double prime? This ethyl. And what's our methyl? So I'm going to keep my eye on the carbon with the 2 oxygens. What's attached to that? Methyl, R prime, ethyl. Are still attached. It's now a ketone. It could have been an aldehyde. And then this R group up here becomes that alcohol. And that's how you do it. So that's how you hydrolyze or reverse the hemiacetal or hemiketal reaction. Remember the last two and this one, next one, I'll never give on a test as a synthesis or the final. All right, let's move on to the next one. Let's do one more of these. I think you could use to practice. Everybody else watching the YouTube later on. And here's one for you to try again. What would be the organic product or products of following reaction? Oh, one thing I haven't done, I better mention now, on a test, I would probably do this. And that tells you there are 2 things you got to get to make. All right, looks like both of you are done. That's nice having a nice intimate class. All right, let's do this. What's different? Oh, look, an oxygen here, one here, and there's 2 the same carbon. And this carbon right here has carbons there, carbons there. It's a ketone, but it's a cycloketone. Oh, I got ahead of myself. Sorry about that. It's not a cycloketone. It's a hemiacetal. Remember, in this molecule, R and R prime are connected together. When you react it with acid and water, keep your eye on the carbon with the 2 oxygens single bonded to it, and that becomes this carbon, which is double bond to oxygen, and R prime, or if it's a hydrogen, and R double prime. And then this R group on the oxygen becomes an alcohol. So if we look here, this is R. Here's my carbon with the hydroxyl group. I'm going to draw that and what's attached to it becomes this ketone, because this is the carbon that was right there. And then what's my R group on my alcohol? The carbon with the hydroxyl group here is the carbon with the hydroxyl group there. And this case is N-propyl, the N carbon of 3. And that's how you do it. Now, let's look at the next reaction. And here, if I have a carbon with 2 oxygens single bonded to it, that gets your tension like that. And each oxygen has carbons on it. And you can have on the carbon with those 2 oxygens R prime or a hydrogen. And our double prime, again, that's like X and Y, just carbons or hydrogens. And now, if we add acid and water, you'll get back, keep your eye on the carbon with the 2 oxygens, that becomes this carbon. And what's attached to it is still attached to it. And then the R groups here become the alcohol. Now watch closely. Notice I put quotes around it too. Why? Well, organic chemists don't balance equations unless we have to. So if you don't want to put the 2 there, that's fine, because I'm asking you what products, not how many. And you get an aldehyde or ketone plus this alcohol, which is the same products as the last reaction. We're just not balancing the equation. So that's something, if you want to put the 2 there, go right ahead. If you don't, don't. If we look at this reaction, the question is, what's the organic product or product? And on a test, I'd put a plus sign there, so you know there are 2 things there. And we look at this molecule and say, what's different? And if you look here, I think you 2 are already cheating and going ahead of me. I'm just kidding with you. But you have an oxygen here, an oxygen single bond, it's the same carbon. Each one has carbons on it. And you got carbons and a hydrogen here. What do we have? This carbon has our prime hydrogens, our double prime, 2 oxygens, R on each one of those. When you add water and acid, what happens? Keep your eye on the carbon with the 2 oxygens. What's directly attached to it, that's carbons or hydrogens, is still attached to it. And then these groups here become an alcohol. Now, if you don't want to put the 2 there, you don't have to, which is why I made it real small. So let's look up here. Here's the carbon with the 2 oxygens. Here's my R prime. Here's my R double prime. Both of these are my R. So now, Keep my eye on this carbon. What's attached to it? 2 carbons, and a hydrogen will still be there. Maybe I should have drawn it over further. And it will be double bond to oxygen and aldehyde. And then my R group is a methyl, so I get methanol. Like I said, you don't have to put a 2 there. If you want, go right ahead. If not. Now, this is the first step in your stomach to break down carbohydrates. If you had anything today for lunch or breakfast with carbohydrates in your stomach right now, this type of reaction, not with this molecule, but with the actual carbohydrates, and we'll come back later on, and I'll show you that when we get into carbohydrates. It's quite amazing what Mother Nature has done in your stomach as going on. In case you haven't figured it out, you are a walking organic chemical plant. All right, your turn. And when you're done, give me the thumbs up. All right, I think everybody's done now. Let's take a look at this. And the first thing you do is look for what's different. What's not carbon, what's not high. Ooh, oxygen here, 2 of them, single bond, same carbon. That only happens in 2 places, hemiacetal, hemiketal, or acetal ketals. And this is got on each oxygen R group. So this is in this case, a ketal. Keep your eye on the carbon with the 2 oxygens, and they'll still be attached, whatever R and R prime R, double prime R, still attached, and this becomes a ketone or aldehyde. And then you'll get your alcohol from this and this. And for those who must, put it to there. Organic chemists like me wouldn't. So if we come up here, this is R prime, doesn't matter what you call R prime or R double prime. This is R double prime, and here we have R. Therefore, keep an eye on this carbon, what's attached to it. R prime ethyl, R double prime methyl, then it becomes the, in this case, ketone. And then my R group is ethyl. And for those who want to, you can put it to there. It's funny, I can tell you a quick little joke. In the past, I've seen students, and I say, I put the quotes there because it means you don't have to put it there. And guess what? They'll put a 2 on the test with quotes. And I always smile and think, all right, I really do affect you guys. Oh, let's do one more. Is that a pretty molecule or what? Now you know I'm an organic chemist. And the question would be, what's the organic product or products are the following? All right, well, maybe not. All right, everybody's done. I wasn't sure if you're done, Samantha. Alondra, I can tell when she's done. So we look at here and what's different. 2 oxygens single bonded to the same carbon. And what is that? Notice I have carbons here and here, and this is a ketal. Add acid and water, water and acid, and keep your eye on the carbon with the 2 oxygens. What's attached to that carbon is still attached to it and becomes a ketone or aldehyde. Then the R's on the oxygen become an alcohol. Now for those who must, you could put a 2 there. I wouldn't if I were doing this for my colleagues. And look at this carbon right here. What's attached to it are these right here. In this case, it's the ring. It's still attached to it. And the methyl group is still there. And now this carbon becomes this carbon. And so you have this ketone. Then, if we look over here, what's our R group? T-butyl group. What carbon? That's better. What carbon has the oxygen on there? We'll have the hydroxyl group. So you get a T-butyl group back. And for those who must, a 2. And that's how you do that. And think about it. This is the actual chemistry that your stomach uses to break down your food. Mainly, well, all of it, and I'll teach you the other reactions too, but for now, carbohydrates. So if you had a piece of bread for lunch, this reaction is going on in your stomach. I didn't want to scare you, but it is. All right, let's move on. And let's talk about the Grignard reaction. And there are two things when we talk about the Grignard reaction. First of all, I should tell you it's named after the great French organic chemist, and actually my hero, Victor Grignard. Hold on, let's do something. And this is Victor Grignard. Don't you love that mustache? And he won the Nobel Prize for the reactions he's famous for. And they were so important, they were named after him, the Grignard reactions. And he's a French organic chemist. Now, the Grignard reaction, first of all, you have to make the Grignard reagent. And that's where you take any alkyl halide and react it with magnesium. Remember, X here can be chlorine, bromine, not fluorine, or iodide. And you form the Grignard. And let me talk about that using the whiteboard. First, I'll let you write it down. This is the right way to write a Grignard. If you write it this way, I'll mark it wrong, because it is. There's no molecule I've ever seen with an R group attached to halogen attached to a magnesium. Here you have an R group attached to magnesium, and the magnesium is bonded to the halogen. And a Grignard, and I'll explain this later, is like R minus MgX plus. It's not, there's actually a bond there, but it's like that. So let's look at an example. These are fun reactions. I've done them and for my PhD thesis to make molecules I needed. I used a Grignard reagent, which I had to make. You can buy it too, but I made my own. And you look for what's different. If you look here, ooh, halogen on a carbon and magnesium. And this is to make the Grignard reagent. And the carbon with the halogen will be the carbon the magnesium is bonded to. So if we look here, what's our isopropyl? And that will have the magnesium, and attached to that is the bromine. And that's a Grignard reagent. Your turn. All right, looks like both of you are done, so I can get moving. All right, what's different? Look for what's not carbon, not hydrogen. Ooh, halogen on a carbon. Ooh, magnesium. And this makes the Grignard reagent. Remember, X here can be chlorine, bromine, or iodide. And what's our 4 carbons? And you know you don't break carbon-carbon single bonds. The carbon with the halogen will have the Grignard attached to it or bonded to it. Oops, wrong carb. Not wrong carbon, wrong halogen. And these are a joy to run in the lab. They're quite fun and simple to do. Oh, let's do another one. I want to try a synthesis. What would I react with magnesium to make that compound? And this is the fun part of organic chemistry synthesis. If you've ever played chess, you know how you think backwards, forward a couple moves before you make it. This is similar, except it's with atoms and molecules. All right, let's take a look at this. Now here you look at the product and say, what's not carbon, what's not hydrogen? Ooh, magnesium with a halogen on a carbon. This is a Grignard reagent. And what do you react with? A Grignard and alkyl halide, where X is chlorine, bromine, or iodine. And for this molecule, that's my R group. And the carbon with the Grignard, this one right here, will be the carbon with the halogen, in this case it's iodine. And that's how you make a Grignard, and they're really fun to do. Now the question is, all right, well now I've made this, what good is it? And now I'm going to show you why it's so good and why Victor Grignard won the Nobel Prize for this. All right, what's happening? Hang in there. I think my computer's dying on me, or the chemistry gods are mad at me. Hang in there. I'm going to try something real quick. Oh, that's not good sign. Hold on, I'm going to do a power. That's back. Let me open up one more thing. And one of the problems I'm thinking about now is in the past when I'd go to school, I'd shut down my computers. I can't remember the last time I shut it down to reboot it. Maybe it needs that. All right, I'm back in business. I think tonight I'll make some offerings to the computer gods. All right, this is the beauty of the Grignard reaction. If you take a ketone or aldehyde, and let me teach you something right here. Organic chemists are lazy. And what this means is I take A, first reactor with B, then after that I react with C to make D. Because we're lazy, instead of putting two steps with arrows, we combine it. So take a ketone or aldehyde, first step, react it with a Grignard. Second step, react it with acid and water. And what you get is what's attached to the carbonyl carbon is still attached to it. But now this opens up to an alcohol, and from the Grignard, you do something very special, very rare. You make a carbon-carbon single bond. And for that, discovering this, the step before to make the reagent and this reaction, and I'll show you Grignard with another functional group later in the semester. Victor Grignard won the Nobel Prize, and this is such a useful reaction. I've used it in my PhD thesis, and it really makes a difference. So let's take a look at it. And now we look at this reaction. The question is, what's the organic product or products? And if we look at this, we say, what's different? Oh, we've got an aldehyde. Could have been a ketone, but it's an aldehyde.
I can't see it again.
Oh, no.
Yeah.
Both of you should have screamed at me. All right, now can you see it?
Yeah, thanks.
Thank you. And up here, first of all, what's different here? Carbonyl to oxygen, a ketone or aldehyde. In this case, it's an aldehyde. Then I have right here, carbon, magnesium bromide. That's a Grignard. Second step, acid and water. Now, the Grignard will form to what was the carbonyl carbon. But first of all, what's on there is still on there. This will open up to an alcohol. And then this R triple prime will form that special carbon-carbon single bond. Very rare, very special. So if I look over here, this is R prime, R double prime, and R triple prime. By the way, I won't do it in this class. Well, I will. No, I won't. I've done reactions where you have R4 prime, or at that point you start using letters of the alphabet or numbers as opposed to prime. The carbon over here becomes this carbon right here. I'll draw it in. What's attached to it? R prime, in this case the hydrogen, R double prime methyl. It becomes an alcohol. And then the carbon with the Grignard, in this case it's two carbons, will be the carbon. That's bonded to the carbon with the hydroxyl group. And notice I've added two more carbons now by making this carbon-carbon single bond. And that's the beauty of the Grignard. Now, one of the things I didn't show you, and maybe this might help, this will never be on a test, and this is called the mechanism. Now, if we start with a ketone or aldehyde and add the Grignard, think of a Grignard as R minus MgX plus. This is an anion on a carbon and it's not happy. And it's looking for anywhere positive it can attack and bond to. And remember the carbonyl carbon is slightly positive and the oxygen is slightly negative. So this is going to want to attack that, and it does. So this attacks that and forms this intermediate. What's attached to that is still attached to it. I form my carbon-carbon single bond, and this opens up to this salt. And this is the conjugate base of an alcohol. And now if I add H plus and water, it will replace this with this. It's an acid-base reaction. And that's how Grignard goes in real life. By the way, Dr. White just had a lot of fun because I love doing mechanisms. But this may help you understand it or just memorize the reaction. I will never in this reaction give a synthesis problem, even though they're fun, but it's not quite for you. And your turn. Why don't you try this one? And when you're done, give me the thumbs up. Thank you. I wasn't sure if one of you were done yet. All right, let's take a look at what's different. Ooh, it's a carbon double bond to oxygen, a ketone in this case, but it could have been an aldehyde. And then, ooh, first step up here, ooh, carbon with magnesium chloride, it's a Grignard. Second step, acid and water. And keep your eye on the carbonyl carbon. What's attached to it is still attached to it. This opens up to an alcohol. And now with the Grignard, you make that very special, very rare carbon-carbon single bond. So if I come over here, here's my R group, R prime. Here's my R double prime. And here's my R triple prime. So what's attached to this carbon is still attached. My R prime methyl, my R double prime ethyl. I get my alcohol. And what's my R group? Methyl. And you've made a tertiary alcohol, which could be useful in many things. With that, it's time to take a break. And I'll see you in 5 minutes at 2:50. And I'm going to go check my mail. right, are you two ready to get going? Let's see. Let's see, Samantha, are you back? You are? Okay. My two regulars, I think I know who's going to get A's.
Sorry, I've got a daughter I was attending to, so
What?
I have a daughter I was tending to.
Oh, don't worry. All right, let's get back to where we were. We're talking about the Grignard. Oh, let's do another one of these. These are fun. And there you go. Have fun. All right, looks like both of you are done. I like this nice, small, personal class. All right, what's different here? Carbon, double bond to oxygen. Remember, look for what's different. The oxygen gives it away. It's got carbons here and here. This is a cyclic ketone. Could have been an aldehyde, but it's not. Remember, in this case, our prime and our double prime are connected together. What's up here? Carbon, ooh, magnesium halide on a carbon, Grignard. Second step, acid and water. And keep your eye on the carbonyl carbon, which is attached to that already, is still attached. Then this becomes an alcohol. And from the Grignard, you make that special thing, a carbon-carbon single bond. Well, my ring is my R prime and R double prime. What's still on the ring, the methyl group will be there. This is my carbon, that's this carbon, that's this carbon, that's this carbon. I'll have a hydroxyl group. And what's my R triple prime? Doesn't matter which side you put the hydroxyl group. My R triple prime is 3 carbons. Which carbon has the magnesium halide, the end one? And there you go. Now, if you look at the molecule I've just made, or you just made, I know of no simple way of making that, or even moderately hard way. I can't think of a way of making that molecule other than the Grignard. With the Grignard, it's simple. And that's the beauty of the Grignard reaction. All right, let's go on. And the next reaction I'd like to talk about is called reduction of a carbonyl compound. Really, it's also called hydrogenation. Now, a long time ago, it seems, for test one, you learned that if I have a double bond, carbon-carbon double bond, and react with hydrogen and a catalyst, I break the pi bond, and each carbon gets a hydrogen. Well, guess what? Same thing happens with a ketone or aldehyde. If R prime is H, it's an aldehyde. You break the pi bond, and each atom of now a carbon-oxygen double bond. And let me draw it here. And notice if I have my pi bond right here, if I break it, what's attached to that carbon is still attached. And then each atom of the carbon-oxygen bond gets a hydrogen. And this is really just an OH group, which I have written like that. And this is hydrogenation of a carbonyl ketone or aldehyde. All right, everybody got this part down? Good. So if I go over to my whiteboard, if I look at this molecule, what's different? Ooh, oxygen on a double bond to carbon. And I have a hydrogen. It could have been carbons. And I also have more carbons. And this is an aldehyde up here. It could have been a ketone reacting with hydrogen and a catalyst. And again, I apologize for those lines shooting out. I like to shoot my computer right now, but I won't. And remember, the catalyst can be nickel, platinum, or palladium. In this case, it's up here nickel. You break the pi bond. What's attached to the carbon over here, carbonyl carbon, still there. And you make an alcohol. So what's R prime, hydrogen? What's R double prime, ethyl? I'll break the pi bond. Each atom of the double bond gets a hydrogen. Now you could have written it CH3, CH2, CH2OH, or this way. Either way works perfectly on a test because I'm the one grading it. Oops, you got it? Everybody okay? Remember, I got the fastest mouse wheel around, finger. All right, your turn. And why don't you try this one? All right, let's take a look at this. What's different? Oh, look, oxygen double bond to carbon with carbons here. This is a ketone. Could have been an aldehyde. And we're reacting with hydrogen. And what's this? Palladium, that's a catalyst. You break the pi bond right here. What's attached to this carbon is still attached. And each atom of the double bond gets a hydrogen. So what's our prime and our double prime? Methyl. And therefore, they'll still be attached to that carbon. And I'll break the pi bond, and each atom gets that. Can anybody see the significance of this reaction? I'll let you think about it, and then I'll tell you. Time's up. If you're ever on a desert island and you need some rubbing alcohol, but you have nail polish remover, you can take that, react it with hydrogen and catalyst and make 2-propanol, isopropyl alcohol, mix it with water. Now you got your rubbing alcohol. Now you know how organic chemists think weirdly. Oh, let's do another one. What would you start with and react it with hydrogen and catalyst to make that molecule? Remember, synthesis is the fun part. If I say fun enough times, you'll believe me, but it's just. All right, looks like everybody's done. Let's take a look at this. And the question is, what do you react with hydrogen and catalyst to make this molecule? What is this? It's an alcohol. And if we look at this, how do you make an alcohol? Reacting what? Hydrogen and catalyst. With a ketone or aldehyde. So this is our prime is really a hydrogen. And if we come over here, because I can rewrite this like this, our prime is hydrogen, our double prime is methyl. Therefore, if I take this aldehyde, I'll react it with hydrogen and catalyst, in this case nickel, and to make that. Oh, this is fun. I got to do one more. Have you do one more? First of all, everybody got that? Now, before I let you loose on this, oh, look, we've got two functional groups. And here I have a bunch of alcohols. Does anybody here know reaction of hydrogen with an alcohol? Because I don't. So it's not going to react. But what do we have here? Well, I'll let you figure that out. All right, let's do this. Well, what's different here? Well, hydrox group, but that's not going to react with that. If I have carbon double bond to oxygen, hydrogen here, carbon's there, that's an aldehyde. This, the R group has all this here. I call it R double prime. And I have a hydrogen, which it also could have been a ketone. And I break the pi bond, and each atom of the double bond, carbon-oxygen bond, gets a hydrogen. And you form an alcohol. Well, here, what's R prime, double prime, I should say, 5 carbons, then it's attached to this carbon right here. And it has a hydrogen. Each one of these has hydroxyl group. And then this double bond was broken, each one. And that's the molecule again. And if you notice, you've got 6 carbons, and each one, including this one, has a hydroxyl group on it. Well, it turns out this molecule, which I'll teach you later on, is called glucose, which when we get into sugars and carbohydrates, that's the most abundant sugar in all of nature. Now, this new molecule, these are common names, not IUPAC, is called sorbitol. And you're probably saying, so what? Well, let's take a look. Don't you love Wikipedia? And if you notice right here, this is a structure for sorbitol. This is the line method. And every bend in the line is a carbon. 1, 2, 3, 4, 5, 6. And notice each carbon has a hydroxyl group. This shows stereochemistry, which I haven't taught you about yet. Now, sorbitol is a sweet compound. If you notice right here, it talks about the reduction of glucose. That means adding hydrogen and a catalyst. And this is a sweet compound. And where is it used? It's used in many different products you can buy. And it's a sweetener, but it's more found in various products you can buy. And one I'm familiar with is any type of over-the-counter product. If you go to any big box store or drugstore and you buy cough medicine, or if you buy other things that are liquid like NyQuil or any of that, if you look at the label, you'll see near the end, sorbitol. That's put in there because it's a thickener, and you've been conditioned if something's nice and thick, oh, that must be good. It's got good stuff in there. No, I can put a chemical in there that thickens things and does nothing else. Plus it sweetens it. And it's a 0 calorie, I think, sweetener or low calorie. So that's where they use it. And you've just learned how they make it. All right, I'm going to write something down on the whiteboard. Please do not copy it down. Well, you can if you want, but I want to illustrate a point. Say you wanted to convert this aldehyde into an alcohol. And again, you don't have to write this down. This will never be on a test or anything, but it illustrates an important point. Well, how many functional groups are in this molecule? Well, you got an aldehyde. Oh, look, you have a double bond too. Well, I know an aldehyde or ketone. Will react to give me the alcohol with that hydrogen catalyst that I want. But I have a double bond and I know that. That reacts with hydrogen and a catalyst. To break the pi bond, each carbon gets a hydrogen. Well, if I don't want to lose the double bond, this is the wrong reaction to run, because I may get some of this, I may lose this, not react that, and what I probably will get mostly or a good amount of is this alcohol. But I've lost my double bond. So what do? Well, it turns out this type of situation occurs a lot in organic chemistry, and someone comes around for a solution for this problem. And turns out somebody did. And that's using lithium aluminum hydride. A great organic chemist, I think he was at Purdue. I always get it, was he at University of Indiana or Purdue? I think it was at Purdue. Dr. H.C. Brown, Herbert Brown, developed the whole chemistry using two reagents, and I'm only going to teach you one, lithium aluminum hydride. Think of this as like a Grignard H minus and the rest plus. And what lithium aluminum hydride does is a similar reaction to hydrogenation, where you break the pi bond of an aldehyde or ketone, and each atom of the double bond gets a hydrogen. Now notice you've got two steps here. And what happens here is lithium aluminum hydride is like H minus, and like a Grignard, it will attack that. And this, what I've just drawn, is the conjugate base of an alcohol. It's a base reacted with acid in the presence of water. And I'll remove this and replace it with a hydrant. You get that alcohol. Now, the nice thing about lithium aluminum hydride is this doesn't react with carbon-carbon's double bonds, only carbon-oxygen double bonds. So the reaction I showed you before, you would get the right product if you use lithium aluminum hydride. And if I were to ask you, what's the organic product or products are the following, you'd look at this and say, what do I have that's different? Oxygen double bond to carbon, carbonyl. It's got carbons here and here. And therefore, I have a ketone. It could have been an aldehyde. Reacted with first lithium aluminum hydride. Second step, acid, water. What's attached to the carbonyl carbon is still there. And then you break the pi bonds like hydrogenation. Each atom gets of the double bond, carbon-oxygen double bond gets a hydrogen. So I'll call this R prime, this R double prime. What's attached to the carbonyl is still there. Therefore, I have my ethyl group and my methyl. I break the pi bond, and each atom of that carbon-oxygen double bond gets a hydrogen. And this you can use in very special cases. Lithium aluminum hydride is a lot more expensive than hydrogenation, but when you're doing things like making medicine that has other functional groups in there, this is one that you use this. And here's one for you to try. Remember, keep your eyes on your own monitor. Oh, that was a lame joke, but you liked it. All right, everybody's done. What's different? Carbon, double bond oxygen, hydrogen here, carbon's there. It's an aldehyde. Could have been a ketone, was R prime is hydrogen, it's an aldehyde. If I react that with lithium aluminum hydride, second step, acid and water. What's attached to the carbonyl carbon? Is still attached. Break the pi bond, and each atom gets a hydrogen. In this case, R prime is a hydrogen. R double prime is isopropyl. What's attached to the carbonyl carbon? Is still attached. You break the pi bond, each atom of the double bond gets a hydrogen. And you know there's 4 bonds to carbon. And that's how you do it. Oh, let's do one more. What would I react with lithium aluminum hydride and acid and water to make that molecule? All right, you're both done, so I better get to work. Because you're giving me that look like get to work. What's different here? Carbon with a hydroxyl group. Ah. And notice this carbon does have a hydrogen on there. 1, 2, 3 bonds, 4 minus 3. There's a hydrogen. We just don't show it. And therefore, what do you react with lithium aluminum hydride? Second step, acid and water to make that? And the answer is an aldehyde or ketone. Here's the carbon that's right here, which starts out of that. What do I have attached to that carbon? The ring. And what this carbon becomes, that carbon. And that's how you do it. Okay. And that's lithium aluminum hydride. And like I said, H.C. Brown won the Nobel Prize. I got time? Yeah. If you notice today, they gave out the Nobel Prize in medicine. What you don't know is, unfortunately, like many things in life, and this has gone on for a while, the Nobel Prizes are quite political. And bad story, back in about the late 70s, mid 70s, someone won the Nobel Prize in chemistry for using molecules that H.C. Brown invented. And if it wasn't for H.C. Brown, that guy would have never done his work. And the chemical community was upset with the Nobel Award Committee. I mean, quite upset, because H.C. Brown should have won it before he did. This other chemist who did good stuff, but they should have never given it to him before they gave. And the next year they correct that, because so many chemists got mad at that committee that they corrected their mistake, and H.C. Brown obtained the recognition award he deserved. I remember I was still in grad school, and my advisor in the whole chemistry department, Michigan State, were very upset about that. All right, this next reaction, I'm going to wait until we get into carboxylic acids. Just cross it off. All right. You know something? I'm going to do something different with you two, and we're going to have some fun together. It's time to play that fun game, circle and name the functional group, 2 points each. By the way, this is an OH right here. This is an H. And there you go. Have fun. Circle and name the functional group, 2 points each. Hope you're all having fun. And when you're done, give me a thumbs up. You both done? All right, let's have that fun game. Circle and name the functional group, 2 points each. Look for what's different. Hydroxyl group on a carbon. That's an alcohol. If your circle is a little smaller and a little bigger, that's okay. Ooh, oxygen with a carbon here. And that's an ether. Oh, look, oxygen here, double bond to carbon, hydrogen there, carbon's there. Well, not best circle, but, and that's an aldehyde. Oh, look, I've got an oxygen here with a carbon here and carbon here. That's an ether. Oh, look, I've got a carbon double bond to oxygen, carbons here and here. And that's a ketone. So there are 2 functional groups. And then E, I threw in everything but the kitchen sink. Now, if we look here, hydroxyl group on a carbon, alcohol. Another oxygen to carbon, double bond to carbon, carbons here and here. And that's a ketone. Ooh, another oxygen here, double bond to carbon with hydrogens and carbons. And that's an aldehyde. And that's how you play that fun group game. Circle and name the functional group, 2 points each. Now, why is this an important game? Well, if you don't know how to identify a functional group, how are you ever going to do nomenclature? If you don't know how to identify a functional group, how are you going to understand the reactions? So it's an important, fun game. Remember, on my test, I'll never include on test 2 functional groups in the same molecule. But in real life, that happens. If I look at the clock, don't tell anybody, but I'm going to let you out a whole 2 minutes early. And I'll see you tomorrow. Hold on, I don't want to. Bye. Gehen gesund. Both of you be healthy. Hopefully some more people will show up. And if not, you're here, and that's important. And I'll see you on Wednesday. Don't forget, the lab is due on Wednesday that we did last Wednesday. This Wednesday, we'll be having a lab on alcohols. I've already posted it in D2L. I guess I'm not going to let you out too much earlier, maybe only 60 seconds. And we'll do that, but don't forget to do your practice problems this Wednesday. I'll do the practice problems on ethers and epoxides. With that, gehen gesund, be healthy. If you have any questions, I'll stick around. Don't forget, I have my office hour tonight.